Now let's review Amazon Simple Queue Service, or SQS. With Amazon Simple Queue Service, we gain a fully managed queue service. And so there's no instance of any kind of server that we need to provision. Nothing is sitting there idle that we're paying for. There's no software to install. We simply go to the Simple Queue Service and create a queue. And then all of the underlying infrastructure necessary to maintain that queue, including high availability, fault tolerance, durability of messages, is all handled by AWS. And so the system itself scales automatically. With the standard queue, we can scale almost limitlessly. And we can control authorization using the identity and access management specifically for users, groups, or roles. We can also use a resource policy, so we can control usage of the queue at the queue itself. And by doing that, we could use a resource policy to share that queue with another account, being it an account that we own or an account owned by a third party. We could also share the queue to anonymous users if we needed to. SQS also supports server-side encryption. So if you are dealing with messages and data such as personally identifiable information or protected health information, then we can leverage server-side encryption using AES 256 to ensure that those messages are encrypted at rest. Now, with the Simple Queue Service, we have two different types of queues. We have a standard queue and a FIFO queue. With the standard queue, keep in mind that the order is not guaranteed, and it does make a best effort. It makes a best effort to deliver it in order, but it's not guaranteed. It's also an at least once delivery model, meaning that it's possible for a message to be delivered more than once. And so your application would be responsible for any kind of either deduplication or ensuring that your operations are idempotent, meaning that if you end up performing the same process on the same message twice, that you end up with the same result. Now with the standard queue, we get nearly unlimited throughput. There's really nothing for us to do to ensure that the standard queue can scale to just about any throughput level. We can send millions and millions of messages through the standard queue, and again, AWS is responsible for ensuring that it scales. AWS handles all of the infrastructure necessary to make that happen. Now we also have first in, first out queues. So with FIFO queues, the order is guaranteed, and it also follows an exactly once delivery. So there are plenty of applications where you rely on the order absolutely, and many applications where you can't afford to do things twice, right? So you need an exactly once delivery. And so if you need order, if you need exactly once delivery, then take a look at the FIFO queue. And so the difference in throughput between these two is fairly significant. Again, with standard queue, we get nearly unlimited throughput, but with the FIFO queue, we do have an upper limit of about 3,000 messages per second if we are using a batch type of operation. So let's take a look at a diagram here. And so the idea with a queue, I'm sure many of us are familiar with queues, some of us may not be, but in terms of queues and how they can benefit our applications, with this diagram, you can see here that we have some type of an application running on EC2 instances, and those are behind a load balancer. So it could be that users are asking for some kind of work to be done, right? They could be uploading documents, and our application on EC2 is responsible for ingesting those documents. Or it could be that they are asking for some kind of report, and then willing to wait for that report to be delivered to them later, right? So either way, what we're looking at here is the first stage of an asynchronous process. And so the idea here is that we don't really want to rely on our backend instances here to perform everything. We want to decouple, for example, if we're ingesting images, we want to decouple image ingestion from image processing, right? We want to decouple a user requesting a report from the report actually being generated. And so the way that we could use this is that within Amazon SQS, within the service, we simply create a queue. And that's all we have to do. We create a queue, we give it a name, and that queue, we get a particular DNS endpoint for that queue. And then our instances sends messages to the queue. And those messages will buffer. They will stack up in the queue. And then our backend instances, here we have backend instances that are responsible for doing the work, whatever that work is. It could be doing some type of an image processing, could be video transcoding, it could be executing some type of report on a large data set that's going to take some time. And so our user has requested it, now they're off doing something else while the report is being generated. And so these systems back here, whatever this is, all it has to do now is poll the queue. So by polling the queue, it can then receive these messages. Once it receives a message, it can then do the work. Once that work is completed, it then deletes the message from the queue. Now, these back-end instances here could be anything. Doesn't have to be EC2. Those could be Lambda functions. They could be containers running within ECS or EKS. In fact, it doesn't even have to be anything on or within AWS. It could very well be servers, traditional servers running on premises. But the idea here is, again, that we are looking to decouple whatever work is being done back here from whatever work is being done up here, so that if either one is down, if our back end is down, then messages can simply continue to buffer and stack up in the queue. And the back end being down should not bring down our file ingestion. We should still be able to ingest or do the front end work until we're able to get the back end back online. And the converse is true as well. If image ingestion is offline temporarily, then our back end can continue to work through the messages that are already in the queue. And so if you have a need for a queue, if you need the ability to send messages between components like this, if you are looking to decouple different stages of your larger application, then definitely take a look at Amazon Simple Queue Service.